Hey everybody, welcome back to another exciting physics lecture. At least what I hope is an exciting physics lecture if you can have one of those, huh? Alrighty, today we are starting a brand new big topic. Really fun one. This will be lots of experiments in class, lots of doing, lots of fun stuff. It's geometric optics. Um, so we break optics into two parts, physical and geometric. Geometric optics has to do with images and lenses and telescopes and microscopes and stuff like that. So pretty fun stuff. So here we go. Whoops. The story we're going to start today, basically how we're going about it is stolen from a guy named Randall Knight, and he writes physics books, and I really enjoy what he does. So in general, that's kind of the path we're going to take the story we're going to tell today. All right, so for today, what I hope you get are two main points. We're going to talk about light as rays. Within that, there are three things you need to get, and then we're going to talk about two different kinds of sources of light. The first one has an A and a B, and the second one has A, B, C, and D. So think about your notes and how you're taking them today, and this is kind of how we'll break things up. All right, so we're going to talk about light as rays. Um, we've talked about this before, so it's not completely new at all. But we've gone back and forth between saying um, talking about wave fronts in light, like the crests of a wave moving along. Um, Sometimes those rays, those crests, are circular and moving out. Sometimes they're plane waves. Um, and we've kind of drawn the rays in there, the direction the light is moving, and that's really where we're going to live for a little while with this geometric optics stuff. It's all about the rays. So the ray is the direction the light is moving, and always remember there's a wave front perpendicular to the ray. Okay. Um, the first two things we'll talk about, rays go in straight lines and they can cross each other. So if you think about you shine a flashlight or maybe even better a laser, and the ray is the direction the light's going. All right. And so we can cross a laser beam or we can cross a flashlight, and that's fine. That doesn't cause any problems. And they go in straight lines. So there's the first two things. Um, Next, oh my goodness, some technical difficulties here. Sorry about that. Got new smartboard software and it's giving me some fits, so hopefully we'll get through this. Number two and or three and four. When light runs into stuff, it can do one of two things. It can bounce off, it can reflect, or it can go into the stuff it hits and refract. Okay. Refraction we've already talked about, and that's done with Snell's law. Notice on here we have theta 1s and theta 2s. We have ends of air and water. We have our light ray. Uh, Now, what we haven't talked about is this reflected ray. We're going to talk about that in a little while. Notice there's no angle on it yet. Uh, so anyway, just know that we're going to move into that one. We'll live with reflected waves and refracted in this little section on ray optics. So, alrighty. So there's our four things. And next, moving down to the sources, if I can get there. The sources of light. So think about a source of light is really an object that we can see. Anything we can see has to be a source of light. Light has to be coming off of it and bouncing into our eyes or going into our eyes. The rays are coming pretty much straight from the object. They might bend a little bit. We'll talk about that, but they come from the object and they go into our eyes. That's how we see them. Okay? So when I say a source of light, that it's an object, it's a thing. Um, And we'll use either one of those kinds of languages. And here's our first thing, um, our first source, objects that we're going to talk about. Two main sources of light. The first one is those that make their own light, light bulbs, the sun. If you make something really hot, like you stick it in a fire and it starts glowing, that's making its own light. You've got the second kind, which is just about everything in the world that we see, and that's where light is bouncing off and into your eye. So in general, light goes like this. It comes from a source that makes its own light and hits a wall or a person or a flower or a car or whatever, and bounces off that and goes into your eye. Okay, so two things. One, things that make their own light, or those that reflect light. Light bounces off. So there we're starting that whole reflection thing that we talked about earlier. Okay, so therein is the first two kinds of sources. We can divide sources into ones that make their own light or ones that reflect light. Now, that's the object itself. Okay, so we're talking about the object itself. Next, we're going to talk about the kind of light that comes off it. So the other way to divide up objects is to talk about the kind of light that comes off. What kind of light comes off of different kinds of objects? Well, here's another way to divide things up. The kind of light. You could have light that has a single ray. Okay, that would be like a laser. That's probably about the best example of that. Number two, you could have things that not a single ray, but a big packet or a bundle of rays that are parallel to each other. Flashlight is a good example. Movie projector, there's another one. So they're a little different than a laser. Think of sitting in a movie theater. You've got a projector that all the lights go in the same direction, but it's big and fat and wide. All right. Next, whoops, jumping ahead, we have the third kind of source. That would be a point source. So it's a pinpoint of light, but the light's coming out in all directions. A great example is a Christmas tree light. So if you've ever seen a Christmas tree light, which we all have, each one of these little lights in this picture could be considered a point source. All right. Each one of these is its own source of light, but the light is going out in all directions. Okay, so it's not going in one direction like a laser, or it's not fat and going in one direction like a flashlight, but it's a small point going in all directions. Okay, skipped one. Sorry, gonna move back up one. There we are. The fourth kind of object is called an extended object, an extended source. So it sends it out in all directions like a little point source, but it's a big object. So think of a light bulb that you're close to, a big light bulb, you know, a regular one you screw in, or most of the objects that we see, tables and cars and dogs and cats and all the stuff that we get to look at are extended objects because light is bouncing off in all directions because lots of people can see them from all around, right? So light's going in every direction, but they're big things. Okay, they're not just point sources. So, oh, we're getting there. Important idea, draw a big line across your paper. This is going to come back to us very quickly. Here's the idea. In this picture, kind of the middle of the pencil is having light bounce into that person's eye. Well, that person can see the eraser end and the pointy end of the pencil. Here's the idea. Light has to be bouncing off those points as well and into the person's eye because they can see the whole pencil. So imagine every point on that pencil having these rays of light flying out from it. All right, they're flying in from some source of light, and then they're bouncing off into the person's eye, and that person's eye is receiving light from all over that pencil. All right, big idea. So an extended object has light going into your eye from all over it. All right, that's kind of the big idea that we need to be familiar with. Those rays are flying in all directions from all different points. Okay, is that all right? See if I can get the next slide. Uh-oh. So here's a question for you. What would stars be? So go back up here in our first dividing up of kinds of objects. Do stars make their own light or reflect their light? Well, that's easy enough. They make it. Okay, so they're objects that make their own light. So next question, number 2. Are they ray sources, bundle sources, point sources, or extended sources? Let's throw out the easy ones. They're huge objects, but they're so far away, we probably wouldn't think of them as an extended source. All right, so they're either a point source, which is good because it's going in all directions, but for us, they could even be bundle or ray sources because they're so far away, we don't really care that light's going in any other direction. It's never going to hit us. So a star technically is a point source, but sometimes we talk about them as ray or bundle sources as well. All right, just kind of an example, something to think about. But again, most of what we live with are extended sources, and most of what we live with are extended sources that reflect light. Okay, so let's see. Oh my goodness. All right, so did you get light is rays, the 3 rules that we had, and then 2 kinds of sources. The first one, making their own light or reflecting, and then the second one, way we can divide up sources as 4 different things, the kinds of sources, point sources, etc., etc. All right, and no video lecture problem. Whoops, I even had an old lecture. It's not oscillations, it's geometric optics. So, hope you enjoyed it. Have a good day, everybody.